volatile day. And now I'd like to introduce Professor Isaac Ginis. He is a very well-known, experienced hurricane expert. So it is hurricane season, and the temperature of the ocean is one of the most important factors in forecasting hurricane intensity. So I would like to introduce Isaac Ginis. He is a hurricane expert, and really scientists didn't know that the ocean temperature influenced hurricanes and hurricane intensity until this man standing right here from the University of Rhode Island pointed that out. So I want to talk to you about your research, your expertise, your knowledge, and just really how that went into your experience in hurricane forecasting, modeling, that kind of thing. But let's start off by welcoming you. So thank you so much for joining us. It's been kind of a different day. Recently, you were given an award from NOAA, the National Oceanic Atmospheric Administration, for your accomplishment for your decades of research. So congratulations on that. Talk to us just a little bit about how you were able to tie the ocean to the intensity of hurricanes. Let's just start with that, because that's really...
Yes, that's an important question. So from the physics standpoint, hurricane is a huge natural heat engine. It converts the heat into the mechanical energy of the wind. So where does the heat come from? It comes from the ocean. In fact, it requires a lot of warm water for hurricanes to develop. So this is one of the reasons they develop only in the summertime. And it requires about 80 degrees Fahrenheit for hurricanes to develop. So they typically develop in tropics. But what is interesting that when a hurricane moves over the water, it actually cools the water underneath. So the temperature gets colder. And of course, one of the reasons is because hurricane draws heat from the ocean. But that's not the main reason for the ocean to get colder. The main reason is that a hurricane, because of the strong wind, creates a lot of currents, very strong currents. And that current churns the water. It mixes the warm water near the surface, which is about maybe 100 feet or so depth in the summer, with a much colder water below. So the hurricane can bring up very cold water from depth to the surface.
That's so interesting.
And that's the main reason for cooling the water. So if the temperature of the water gets colder, then hurricanes get less energy, becomes less intense. So actually the role of this ocean temperature in the hurricane intensity has been recognized well before I started to do my research. My primary contribution was to put this into a computer model that predicts the hurricane intensity. So we have developed what we call a coupled hurricane ocean model that simultaneously predicts what the hurricane is doing in the atmosphere and also what the ocean is doing underneath, to predict how much temperature is changing underneath the hurricane, so we can more accurately predict how strong the hurricane is going to be.
It's fascinating, and to think that you were able to come up with this, and it's science that we use, that we need, right? It's science and modeling that people count on for their lives, right?
Yeah, well, typically when we know the hurricane is out there, we ask two questions. First question is where the hurricane is going. Yeah. The second question is how strong it is going to be.
Yeah, how strong. Okay.
So essentially my work has been focusing on the second question, how strong the hurricane is going to be.
Okay.
We do need to know whether it will be a category 1 or category 3 or stronger. And that is still very difficult question to answer. We're making progress. Of course, the ocean, we argue, plays a very important role. But there is other factors in the atmosphere that affect hurricane intensity. In fact, this is one of the still most challenging problems we are facing in terms of hurricane predictions. We made huge progress in forecasting the hurricane track. We can now predict 5 days in advance where the hurricane is going to be, as accurate as we predicted 10 years ago, 3 days in advance.
Oh.
So we can really now have a significant confidence in knowing where the hurricane is going. So there will be no more surprises like in 1938 storm, when people on Rhode Island woke up in the morning, didn't know that the hurricane will come in the afternoon.
Right here, yeah.
This is not going to happen. So, because we have satellites, we have other observations, we have skillful computer models.
We have you.
Well, but still, there is a significant challenge to predict how strong the hurricane is going to be.
So let me ask you this: what is the current census in the scientific community now that we have this computer modeling, now that we have the satellites, now that we have all of this technology at our disposal? What is the kind of scientific consensus in the community for hurricanes this year and the next coming years, for hurricanes within the next few years, and then we'll get to this as we move forward. When it comes to ocean temperatures, as we move forward in the next few years, what are we looking at? What are we expecting? What are we thinking?
Well, I would separate these two questions. One is predicting hurricanes in real time. Mm-hmm. This is what I do, and if in my research, helping the National Hurricane Center to be able to predict to make the most skillful predictions. So people can prepare for incoming storms, predictions of the track and intensity. So the Hurricane Center does predictions 5 days in advance, 4 times a day, every 6 hours. So we talk about the short-term weather forecast. The prediction of the hurricane season is a different question. And frankly, I don't know how useful actually that information is, because typically we have about 12 tropical storms and 6 hurricanes in the Atlantic Ocean every year. Well, in average. Sometimes it's more, sometimes less. But if we have even more hurricanes, if they all ended up being open ocean and not make landfall, it doesn't make much difference. But if a hurricane makes landfall in the place where you live, this is an active season for you.
Yeah.
Right. So I think it's interesting from a scientific perspective. It's probably interesting to discuss in the media, but from a practical perspective, it's really not that important. What is important for us is to be prepared every year to face a potentially significant impact. So I'll give you an example. In 1992, we had a very slow hurricane season. It was only 7 tropical storms, so less than average. And then we had Category 5 Hurricane Andrew that made landfall in Florida.
It was devastating.
Right, so don't make any connections between the hurricane activity this summer, next summer, with potential threat of a hurricane making landfall in the place where you live.
Okay, I like that. So you do a lot of work to help preparedness within the community, and so you see the pictures flashing behind us, and I'm going to see if we can maybe just pause on one, but so talk to me a little bit about just this past week that you put in quite a bit of work, you and your team, to help with a potential scenario. You called it Hurricane Rhodey. Talk to me just a little bit about your work. I'm not even going to set it up. I'm just going to let you explain what you've done and how you're helping with Rhode Island preparedness.
Yeah, let me first talk a little bit about why we started this project and how it was started. So,
yeah, please do.
After 2012, the year when we had Superstorm Sandy, and Sandy, by the way, wasn't even a hurricane in terms of the wind when it made landfall. And yet we ended up having the second costliest hurricane in the U.S. history, $68 billion. It affected 24 states, including Rhode Island. And many people were surprised, actually wondering, seeing such a large impact from not very strong hurricane. So you might ask the question, what to expect if the hurricane like Hurricane Carol, 1954, the last Category 3 storm that we had in Rhode Island, if that would come today, what we should expect? Now, is the Hurricane Carol the worst case scenario? In fact, computer simulations show that it could be much worse. So we may actually experience a storm that's much stronger than even Category Hurricane Carol in 1938 storm. So last year, we started a project funded by the Department of Homeland Security. This is part of the Department of Homeland Security Center of Excellence for Coastal Resilience at the University of North Carolina. So we are one of the major partners in that work. And we focus on this question. And what is the high impact storm in Rhode Island?
Okay.
What to expect? So we use computer models, and in fact we have a deep team of scientists who have expertise in modeling of Narragansett Bay ocean currents, simulating waves, simulating storm surge, simulating hydrological models to simulate inland flooding. So it's a really large team of scientists who work on this project to create a scenario of potentially high impact, could be catastrophic impact in Rhode Island, so we can show to emergency managers, to decision makers, first responders, what potentially we should prepare for. And that's the main goal. So as part of this work, we created this hypothetical hurricane, we call Hurricane Roddy.
Okay.
Which is kind of a combination of historical hurricanes that made landfall in Rhode Island, but in worst possible way.
Okay, so you're taking data used from historical storms.
So
Okay.
it has some features of Hurricane Carol, some features of 1938 storm, and some features of Hurricane Sandy, and also some features of Hurricane Esther. In 1961, it was a hurricane that was moving towards Rhode Island, then made a loop.
That's what that thing was.
And that Hurricane Roddy is actually making 2 landfalls in Rhode Island.
Wow.
The first landfall, and then it makes a loop and comes back 2 days later. And so we have simulated, as part of this scenario, is the winds, the coastal flooding due to storm surge, waves, and also rain and river runoff to simulate what would be the coastal inland flooding in Rhode Island. Another interesting thing we looked at is on the hurricane barrier, Fox Point hurricane barrier. Hurricane barrier was built in the early 60s, right after we had this few busy hurricane seasons in the 50s, but it was never tested in a real storm. And we can put a hurricane barrier in a computer model and see how well it will perform. In fact, I can tell you that we did simulate Hurricane Carol, and Hurricane barrier worked perfectly fine, as designed. But unfortunately, the Hurricane Roddy scenario would overtop the hurricane barrier and will bring the flooding into the downtown Providence. And what actually might be worse, the second landfall, when a hurricane comes second time, 2 days later, will dump a lot of rain. It won't be much wind, but will be up to 10 inches of rain. But if the barrier kept closed, then the river runoff from the rain could flood the downtown Providence even worse. So what we're seeing here is the images of the flooding, especially this here, downtown Providence, flooded. This is Fields Point flooding, up to about 15 feet at some locations after the second landfall. So this scenario we provided to the training exercise was done by Rhode Island Emergency Management Agency last week. And those simulations, by the way, was done not only in terms of the simulation of water, but also we collaborated with a scientist at the URI Department of Marine Affairs who also simulated the impact of the storm on the buildings, on the critical infrastructure, and they created this beautiful three-dimensional visualizations. So people, emergency managers, can actually see with the great details of the locations where potentially to expect the highest impact. So we created these images every half hour in the course of hurricane making sort of landfall with a progression every half hours. So you can see the event unfolding in front of your eyes. So for the first time,
Wow.
we believe we can show the decision makers the spatial effect, also the time series. So if we could have provided this in a real-time event to emergency managers, that will definitely help them to make more informed decisions of how to deploy the people and how to prepare for evacuation and all other things that needs to be done. So that is, to me, is really a state-of-the-art application of the computing technology, not only predicting track and intensity of the storms that we have done in the past, but also predicting the impact at the specific locations. And so we're hoping this project will continue, and then we will be able, in full interactions with the decision makers, with the REMA and other people, to customize this. In fact, we want to talk with people who are responsible for preparations, hospitals, nursing homes,
Yeah.
who can use this information and to better prepare for future storms. It's not
So when we're looking at this, I mean, this is essentially, when you look at something like this, this is all of downtown. So this is worst case scenario. Obviously, the biggest impactful storm possible when you're looking at Hurricane Rhodey. But can information like this help with a Category 1, Category 2, Category 5 storm if something like that happens? If that's not, this is a pretty
Yes,
bad scenario.
well,
but when you look at information like this, can this help first responders and places like hospitals? Because you're looking at all of downtown. So we're looking at hospitals, we're looking at nursing
Yes.
homes, we're looking at preservation societies. There's a lot of
Yes,
that happens in there.
absolutely.
Can
So
something like that help move forward? When we're not looking at worst case scenario.
yeah, absolutely.
But
So again, this idea of showing the worst case scenario is to help us to better identify where the most vulnerable areas are, so we can prepare for the worst. But the same technology, the same computer models that have been used, hurricane models, ocean models, wave models, hydrological models, and used to create these scenarios, can be used for any storm. In fact, our goal is to make these tools available for any hurricane making landfall in Rhode Island. So we can provide this information to the decision makers and to better prepare for future storms. So this technology, and by the way, this is a sort of a case study that we convinced the Department of Homeland Security to focus on Rhode Island. We're the small state. One of the advantages we have that there is a very close link between the modeling communities, academic communities in Rhode Island, and the decision makers in Rhode Island.
Yeah.
It's much easier for us to reach out to Rhode Island emergency management agencies that it wouldn't be maybe in the bigger state.
yeah,
So that's a big advantage. So we are very excited about actually working with local, state, and officials, and this is work in progress. We're still looking for feedback, for comments, and we are already getting good comments after the training course that we had, we participated last week. So this will continue. So that's, I think we're extremely excited about making this really tangible, important contribution to Rhode Island citizens.
Is this almost? I mean, when you look at this, this is concerning to me, right? I mean, that's a lot of red. Is this almost a wake-up call that people need to pick up their game in terms of preparedness and make plans?
Well,
Do you think?
I certainly hope so. I hope it's so, because this is for the first time we can actually show visually.
Yeah, it's a visualization.
And using state-of-the-art technology, computer models, and visualization to help us to understand our vulnerability. And even for the planning, for the planning purposes, we probably need to look at this kind of scenarios.
Do you think? And you said this is a federally funded project, right?
Yes, it is funded by the Department of Homeland Security.
Okay. So is there any chance that funding could stop? This seems like a pretty important thing,
It
right?
is.
We had Sea Grant in
So
here
we're
last
hoping
week.
that the funding will continue for another 2 years.
Okay.
But that will depend, of course, on our performance and also on how effectively we can get engaged the Rhode Island community in using this information. This is very important. We're excited about the scientists to be able to produce these results. And now we need to make an important next step, is how to utilize this information. And that will be very much dependent on how we can work with REMA, with Rhode Island Department of Environmental Management. So there's many different things we can look at. For example, debris deposited into Narragansett Bay.
Yeah.
Oil spill and potential contamination of the Narragansett Bay water. So that additional modeling that we could do. And we are actually in the process of discussing scheduling meetings with different decision makers in Rhode Island and how this work can be utilized most effectively.
Okay, because this is brand new information, right?
It is very, very new.
It's brand new, so we're excited to be able to bring it to you.
It's
So
really of the print.
That's very exciting and brand new information. And that's and what you said, the debris. That's what we were just thinking about. Brand new information. Just looking at this, the area, the impact. I mean, that could be washed out, right? I mean, just all washed out. So very interesting. Isaac Ginis, hurricane expert from the University of Rhode Island. It's been such a pleasure to chat with you, to find out about the new information that you're bringing to us and the continued research. It's been such a pleasure. So we appreciate having you here. So thank you so much for sharing that with us.